We really appreciate all of you taking some time out on a weekday evening to join this webinar. So thank you so much. So this is the first episode of Techies Talk, and today's topic is handwriting recognition with AI. So these are the agendas for today. So we'll start with the company introduction, and then we will move on to the main presentation. And after the main presentation, we'll have a 15-minute Q&A session, and then we'll have an ending remarks. So before we go to the main presentation, I would like to briefly introduce you to our company. So I presume most of you do not know about our company and our business. So just a brief introduction. So this is Duke, our founder, who established Tokyo Techies 3 years ago. So Duke is a very accomplished software engineer with over 13 years of experience in some of Japan's biggest tech companies, such as SoftBank, Rakuten, and Line. He was a senior technical advisor at SoftBank for 4 years and was involved in many high investment projects, including the one where he brought in Alibaba Cloud to Japan and established SoftBank Cloud Corporation. As a company, our mission is to be trusted partners of both SMEs and multinationals and provide them with required resources to overcome critical challenges and create long-term value. Though we are a fairly new company, but we have provided our services to more than 30+ clients in past 3 years. And some of our notable clients include SoftBank and its joint ventures and subsidiaries. For instance, MeTruck here is a joint venture of SoftBank and Nippon Express, and Japan Computer Vision Corporation is a subsidiary of SoftBank and is an AI company. Other than that, we have also provided our services to other big companies such as Shonan Seminar and Oyo Japan, etc. We provide our services in basically 4 core areas, and those are data science and AI, mobile web system development, cybersecurity, and cloud computing. And we provide our services to all the companies regardless of the industry. So we provide services to companies in industries such as financial services, human resources, logistics, telecommunications, etc. Now, as we are here to talk about AI, I would like to briefly explain what or how Tokyo Techies help businesses with AI and data science solutions. So our AI engineers and data scientists are experts in designing data-driven systems which can monitor and predict anomalies beforehand, which reduces our customers' time wasted on manual configuration and troubleshooting. A recommendation system is something that is very common nowadays. I mean, it has become a part of our life. So most common examples are Amazon and Netflix. So these companies use this recommendation system to recommend you movies, TV series, or consumer goods based on your streaming and purchasing patterns respectively. So our team can create this recommendation system for our customers, which again, in turn helps them to understand their customers and enhance their user experience. Yeah, again, this is also very common. I guess if you visit any website or you are using any app, you can find these conversational tools, aka chatbots, answering your questions or interacting with you. So our team can design these conversational tools for our clients, which helps them to increase the customer engagement and then generate a lot of data and insights on their customers, which in turn helps them to improve their services further. Now, Tokyo Techies have been involved in many AI projects before, but the one notable AI use case I would like to explain about is the classroom behavioral analysis system that we developed for Shonan Seminar, which is one of the biggest cram schools in Japan. So Shonan Seminar wanted us to create a classroom analysis system which could monitor students to optimize learning. So this system basically analyzes the student's pose and then infers whether they are being attentive or distracted in the class. So that was it for the brief introduction of our company. And now we'll move on to main presentation. So before we move on to main presentation, I would like to introduce our keynote speaker today. So this is Khan, who is a senior AI researcher in our company. And Khan is a PhD in computer science. And he got this PhD in Tokyo University of Agriculture and Technology, Japan. And he also worked as an assistant professor there. And yeah, his research include handwriting, and his results. The results of his research are used by many companies such as Metamoji, Wellstock, Kobun Shoin, and he has also published a lot of academic papers and also has one international patent. So I'll pass the baton to Khan now. So Khan, you can start.
Thank you, Manny. Okay, so hello everyone, and thank you Manny for introducing me. It's my pleasure to share everyone my favorite topic. Today we will discuss about will AI change the way we write and draw in the future. And I hope all of you will find some nice thing in this webinar. Okay, this is the content for today's presentation. This includes 7 sections of the handwriting, including drawing and tutorial. Let's start with some introduction about online handwriting. Okay. So first of all, I want to make a small survey. Yeah. Wait a minute. I will turn on the phone.
There is issue with the phone. Start the phone. Oh, next one.
Oh, okay. So you can type in the chat box your option about this question. So when you want to store information, which methods are the most convenient for you? So you can choose multiple choices: writing, drawing, typing, voice, recording, or the others. So please type in the chat box. Sorry, we have some problem with the phone. So yeah, it's now a little bit inconvenient for you. Okay. Okay, thank you everyone. So I got many answers here. I think that many selection is about option C, typing. Okay, so typing is the most selected answer. Back to the high school time, I think the most answer would be the handwriting. But now it's easy to see that we all have at least one digital device that allow typing, and we type every day. Let me point out some reason for that change. As you see in this table, the typing and handwriting have their own strong bond. I will briefly explain about each bond. Firstly, about the speed, I assume that all of you have the same period of experience in typing and writing. So it's not hard to say that the speed of your typing is usually faster than that of your writing. Secondly, about the accessibility, in my opinion, both of them are equal. Smartphone and laptop is always with us, while we can find a pen and paper everywhere. About the third, learning, one of the major benefits of the handwriting, I can say so. Researchers found that students who take notes by hand tend to learn more than those who type their notes on a laptop. And the fourth thing, the flexibility. I think the handwriting is the winner here. You can write everything, including text, table, drawing with the same pen and paper. And the last one, the editability. So you can add, remove, or revise your typing while keeping the format clean and clear. I think you cannot do that easily with your handwriting. So the question is, could we combine the advantage of both methods? In my opinion, I would answer yes, by digitalizing the handwriting. So here we have two ways to digitalize the handwriting. First, you can write on a touchscreen device by your finger or with a stylus. Another way, you just need to capture a photo by your smartphone camera, or you can scan a document. The first way, we call it the online handwriting. It's a time sequence of attentive coordinates. So in terms of an AI perspective, when recognizing it, this input is robust to stock connection and distortion. On the other hand, offline handwriting is a photo. So AI does not need to care about the stock order and duplicated stocks when recognizing. So between two types of handwriting, the online handwriting and the offline handwriting, today I only focus on the online handwriting. However, you can ask me anything about the offline handwriting or demand a separate webinar for it. Back to the reason why I choose the online handwriting. The first reason is that we need a small memory to store data and recognition models. Like an application on your smartphone, it should be small enough. The second reason, the online handwriting has less background noise, so it makes the recognition more accurate. The third one, we can interact with the online handwriting, but I don't think so with the offline handwriting. And the last but not least, the online handwriting has more information for recognition than the offline handwriting. Hence, its accuracy is higher. Okay, so I have another question for you. So, do you have any experience on handwriting or drawing on any devices, like the tablet, the smartphone, your laptop, everything? So you please type the answer on the chat box. You can choose frequently, or sometime, or rarely, or not at all. Let's see. Okay, yeah, a lot of answer. Many people choose A, many choose C, and also some people choose B. But I think the A and the C is the most answer here. Okay, thank you. So for the C option, I think the reason that there are few applications that allow handwriting on the market so far. So you do not have a chance for experience by yourself. So it's okay. Don't worry about that. It's my opportunity to introduce you the handwriting technology nowadays. And some of you, some of the technology and some of the application, I think will become popular in the near future. So before that, let's review a bit on the history. So you can see here, this is the first computer using pen. It was invented in the middle of the last century. And when do you think the first computer mouse were invented? At the same decade before this or after this? Okay, so the answer may surprise you. 10 years after the first computer pen, the first mouse were invented by an American engineer, Douglas Eschenbach. And you can see on the left figure here, this is the device, look like the Wacom device nowadays. And in 1990s, this decade is the beginning of innovative products for handwriting. Here I show two examples from Sony and Apple, the Sony Palm Top and the Apple Newton. Maybe some of you already used this device before. I think so. Okay, so with the many different technology accumulating in the previous decades, recent years, I can say it's the time for the touchscreen technologies to really flourish. The touchscreen devices are getting more popular with the smartphone. Have touchscreen, and we also should mention that we have a lot of stylus today. It's because that some devices or specific tasks require high accuracy in writing and drawing, or just simply that we are familiar with writing with a pen rather than our finger. And from here, the demand of the handwriting recognition become critical. So we already know that a lot of touchscreen device in this day. How about the applications for the handwriting or drawing? So on the left figure here, this is the most popular applications. I think, yeah, this must be the annotating applications. And many annotating software now allows handwriting and also drawing with the recognition function. And on the right side, we also have another application on e-learning. I believe it will be used frequently in the future. As you see, AI can recognize and solve the handwriting equation very fast. And another application I want to show you, this is the Google Translation. I'm sure that many of you already use the Google Translate by writing on your smartphone or on your laptop. Here's an example when you want to translate from English to Japanese. You see, it's so convenient, especially when you travel to the other country. And on the right side, you can see this is the signature verification. This is the one application that I think many companies really want to do now. Okay, the left video showing a person right in a car without looking at it. He may ask the car to show the way to Peter house by writing his name. Yeah, this application already appear on many cars like Nuance, Audi, or Mitsubishi. And on the right side, with this kind of application, input a diagram to a computer will become easy with your handwriting recognition and also drawing recognition. And after the recognition, you can interact with it, modify and revise everything about your diagram. Okay, so this is the most interesting application to me. Here I show in this line, I show 10 lines of handwriting. And some lines are the real handwriting. Some lines are the handwriting generated by AI. So in your opinion, which ones are real? And if you can give some reason why you think so. So please make a guess by typing in the chat box, or you can speak directly. Yeah, I will use some time to look at it carefully. Yeah, because I know it's very difficult for you to distinguish the real one and the fake one. So this is the multiple choices. You can select many lines. We did not get any answer yet. It's very difficult. Yeah, okay, take your time. Yeah. Okay, we have some answer here. 2, 1, 2, 3, 4, 5, 6, 10. Okay. Okay. Yeah, we have many answer here. Yeah, a lot of answer, and all of the answer are different. Okay. Thank you so much for your answers. Okay, so the correct answer, I will show it. The number 1 and number 6 are the real handwriting by human, and the others 2 to 5 and 7 to 10 are the synthesis handwriting. Yeah, it's so hard to distinguish. I know. So, but the AI doesn't stop at this stage. Even better, do you believe that AI can make your handwriting cleaner and easier to read? So, watch this carefully. So, it's really improved a lot, and I can say AI is so wonderful. Yeah, I spent most of my childhood to improve my handwriting. It's about 10 years or more than 10 years. I believe that many of you have the same experiment, have the same experience as me. And then we all use keyboard for input to the computer. Yeah. But now even worse, AI can write even better than me within a day of learning. Yeah, I can stretch out within a day. So unbelievable. So from this point, I already introduced you some small example that what handwriting recognition can do recently. But it's just a start for the handwriting application, because the performance of the handwriting recognition is still limited. So in my opinion, the more accuracy of the AI performance is, the more popular the handwriting application are. So how about the challenge of handwriting recognition? In human point of view, we need a lot of time to learn a new language. So does an AI face the same challenge as we do when we learn a new language? Let's figure out. Okay, so this relates to the first challenge. We all know that Chinese language has the most characters, but how many? Here we count both simplified Chinese and traditional Chinese, and I have 4 selections for you. You can type it down on the chat box. Option A, 10,000 to 20,000. Option B, 20,000 to 40,000. Option C, 40,000 to 60,000. And the last option, over 60,000. Okay, now we have many answers here. Yeah. Okay. Thank you. Yeah. I thank you for your answer. We can see that the most select answer is option D, over 60,000. And according to BBC, there are around 50,000 characters, which is option C. Okay, so but it's still a lot of character, you see, and it may take a lot of years for a person to remember that amount of characters. But for computer, I think it's not a big deal because the AI can only need several days or several weeks to remember all that amount of characters. Okay, so first I already talked about the first challenge about various characters in some language. And the second challenge is about the language specific adaptations. Here I show 6 kind of script, and can you read any of them? I think that you can read at least one in this 6 script. I think so. Okay, so let's start with the first one. This is the Vietnamese. Vietnamese is similar to Latin script with a large number of diacritics on many of the characters. Each diacritic also counts delay stop with a huge challenge for online recognition. I think many of you may wonder, what is delay stop? So delay stop happens when you finish the previous character after writing all the characters. Let me give you an example. The word 10. Oh, sorry. You see here, this is I finished the letter E first, and then letter N, and then I finish the letter T at the end. And this stop, we call this is the delay stop. And this is a huge challenge for online recognition. Okay, the next, this is the Arabic script. And in this script, characters within a word are connected to their neighbors, and it makes the segmentation really hard. Segmentation, I mean the segmentation for the AI engine. And in addition, most characters have different representation that depend on their position within the word. And it should mention about the writing order for this language. So basically, the Arabic script is written from the left or from the right to the left, but number and words in Latin script are written from left to right. So they make the language bidirectional, left to right and right to left in the same language. And the remaining script are written in Korean, Hindi, Khmer, and Lao. Their combination rules are very complex, and some characters even change their form when combining with the others. Okay, so the computer must learn all of these things. And yeah, we should not ignore about the mathematical language. It's the specific language for everyone, so universal language. And most of language have 1 or 2 direction, left to right, right to left, top to bottom. But here in the mathematical language, we have 6 relations: the right, above, below, inside, subscript or superscript. Yeah. And in addition, grammars in mathematics cannot be covered manually and tend to increase over the time. So all of these things make the recognition really challenges. Okay, so we move on. The third challenges. This is the unlimited writing style. So here I show you a writing style for the same script, the rugby in English. So AI will be better when they have ability to learn a wide range of writing style. And number 4, the ambiguous character. these character will be a huge challenge to recognize when they are handwriting, yeah, because they are the same, even for human. Okay, so the last challenge, how can you read the characters? What do they mean? So please type your answer in the chat box. Yeah, I think there's many answers you can see from 3 character here. Yeah, 105 iOS, yeah, iOS, and 10 seconds, yeah, 10 seconds, iOS. Okay, thank you everyone. So this question have no correct answer because it's no contest here. People can, every of you can understand by your own, and I cannot say this is wrong, this is true, yeah, because we don't have any contest here. Let's just imagine that someone give you a paper with this character. What did you respond? Yeah, it's very hard to read these kind of characters. And another example is you can see it might be clock, it might be dog. It depends on the reader. And when you try to read your friend handwriting, you may meet some situation like this. So this is true or false. Yeah, it depends on you. Okay, so AI is the same as the reader. They may confuse the ambiguous words without any context. And it's hard to satisfy user expectation because user expect perfection and understanding what they mean rather than what they wrote. Okay, so here I already introduced you 5 main challenges for the handwriting. Of course, there something more about the challenges, but this year I just introduced the main. Okay, so how do I deal with these challenges? I will not go to detail of the technical solution because the audience today come from many different fields, and AI technique may be very complex for some of you. So that I just talk about the idea of the solution. And if you want to investigate more about the technique, you can ask me in the Q&A section. So the first method is the segment and decode. We call that the traditional method. So here I will segment the whole input into many segments. You can see here the AI segment is into letter I, letter S, and the dot. And then it will try to recognize each segment. Finally, it will combine all the recognition and choose the best one. The second method is we call that the continuous method. It includes the CTC end-to-end recurrent neural network or long short-term memories. This method performs the same task for every element of a sequence, with the output being depend on the previous computation. So they have a kind of memory which remember information about what have been calculated so far. So before applying any method, pre-processing is always the first step to deal with any problem. And here I show some very basic steps belong to the pre-processing. Here, this is the input. And here, the first pre-processing is the sign normalization. Here, you just simply increase the size or reduce the size, and then you can make all the input into the standard size. And then resampling, it means that you just select some important point in a second and remove the other. So result that the output sequence is about maybe 4 times shorter than the original input. So it makes your training, predicting, recognizing must be faster. And this is the overview of the recognition architectures. You here, you can see we have the input. This is the raw input. We can use some kind of the other features, and this will go directly to the bi-directional STM layers. And here you can use 3 to 7 layers, depend on the complex of the input. And then this will go to the submark layers, and from this layer it will give a score for each recognition, and then we will use the decoding method to choose the best recognition based on the score. Okay, so the key technique here is the LSTM, the long short-term memories. It's based on the concept of the human brain. So let me take an easy example for you to understand. So when you read, you understand each word based on your understanding of previous words, and you don't throw everything away and start thinking again for every second. And traditional method or traditional neural networks cannot do the same as our range, but LSTM can address this issue. They are networks allowing information to be remembered. Okay, so how about the results? You can see in this figure, we compare the traditional method and the continuous method in many languages, and both methods are tested on the same dataset for each language. And you can see in this figure, the LSTM method outperforms the traditional method on every language, nearly always by 20+%. Okay, so I think this that's enough for the technique for everyone. So we move on the drawing section. This section will show many things that you may use right after this webinar. Have you ever had any difficulties on inputting mathematical symbol? So this is one solution for you. You can draw it and get the image or the code directly from the website. I insert the hyperlink in the underlying works here. So if you want to try it out, so please drop a message in the survey at the end of this webinar, and we will send you the slide. So back to the drawing application. This is two applications that for you to find the symbol, and you do not need to find it in the ended list. Just draw it, and many options come to you. And you see a heart on the left side and a bicycle on the right side. Okay, so about the quick draw games, I think many of you already know this one. Google AI will challenge you to draw pictures of an object or an idea, and then use AI to guess the drawing. I will show you how to make the similar drawing games in the later slide. Another funny thing is to draw with your friend in your real 3D world. Okay, this is also an application from Google called Just Alive. Let's move on a higher level of AI in drawing. So here AI can help you to complete your drawing of a mosquito, but not only mosquito here. You can choose any model you want. It's also have option everything in this application. And whenever you write something, the AI will try to predict what you will draw next and try to complete it. Okay, so back to the questions in the topic, in the main topic of this slide. So, do you think will the application using the handwriting become the basic daily life application for everyone in the near futures? So, yeah, in my opinion, I think it's possible. It will happen when the performance of the handwriting is high enough, and in that time, handwriting take it on. I mean that let's imagine that you can with a pen and a digital paper, you can write text in many languages, English, Japanese. You draw tables, you draw some figure, and even the music sheet. And then the handwriting can recognize all of these things for you and then turn it into the editable format like Microsoft Word. Or even they can play a music for you. Another application is e-learning. I think it's will popular, mainly used for the student, the people, or the human who want to sell learning like the Coursera now. So it's very helpful. And yeah, there's many more. Okay, so the next question is, how do you think the AI can infer your personal information from your handwriting or your drawing? So recent research show that your personal information can be revealed from your handwriting or your drawing. Like your predict your disease. Yeah. So this can predict your stress, Alzheimer, Parkinson, and so on. Many of diseases. It's based on the something like the features we call that on-surface movement and in-air movement when you're writing. Another thing can infer from your handwriting is your behavioral biometrics, like your dialect, your origin, gender, age, yeah, everything. And also the biometric security. So yeah, for example, the signature verification. And yeah, and in the future, I think that just based on your handwriting, we can identify you. Okay, so tutorial time. Because the limitation of time, so I just show you how to make the drawing games in some simple step. My purpose is that everyone can do with the basic knowledge of Python, no AI knowledge required. And this is a data set for the withdraw games, and we will borrow this data set and train it from it. And this includes 50 million drawings in 345 categories stored in around 22 gigabytes. Okay, so this is an architecture to achieve the not the best but the very good recognition, which include 3 convolution layers and 2 LSTM layers. I think many of you may try this one and will train on your normal PC. So in the shortcut in later, I only use the symbol CNN. So it will be faster when you train. And yeah, of course, you do not need to implement it. You just need to download the shortcut we provide in the next slide. Okay, so here are 5 steps for you to follow. First, download the tutorial project. It includes the shortcode. The withdraw.a file is the model, the pre-training model that I trained already. But it's only contain 10 categories. and requirement for some package in Python. Step 2, you install Python and install all the required package. Okay. Step 3, if you want to train the model by yourself, so you can go to the Google website and select any categories you want for your game. And then you can train the data by running this line, and please will be patient until the training is done. And finally, if you do not want to train by yourself, you just want to run the game directly, so you can skip step 3 and step 4 and run step 5. And after you run this step, it will open your webcam. Yeah, I will show a demo for that. But if you want to make something else, you can do it easily after you get the pre-training model. Okay, so this is an example. I make a game that you can draw directly on your webcam. Here, I draw with the color object, so it will recognize the object, the yellow object as a pen, and predict my drawing. Okay, so thank you everyone for listening my long presentation. So it's time for question and answer. So please give any question or any comments on the chat box, or you can unmute and use the raise hand function and speak out. Yeah, any question, any comments are welcome.
There is a raise hand. There is a raise hand.
Hello.
Okay. Yeah.
Hello, can you hear me?
Okay. So I see one someone raise
Hello.
hand. So please unmute your microphone and yeah.
Okay, hello, listen to me. Okay, I am from Taipei.
So please say your
Hello, yes.
speak out your questions.
Khan, this is Satish speaking. Thank you for your presentation. It was really well presented, and I learned a lot. It was really interesting to know that the trick of true and false, if had I known it before, I would have used the same in my primary school. Can you listen to me? Hello? Hello?
Yeah.
There is quite an echo. Hello? Hello, Khan?
Yeah. Sorry.
Okay, Khan. So yeah, so my question is like around the in the last you showed about a quick game that you can download and then play it by yourself. So
Yeah.
I guess this thing that needs training on neural network, how long should it take if I run it on my laptop, which is a CPU?
Okay, so it's okay now. You can hear me clearly.
Yes, I can hear you clearly now.
That's good. Thank you. Okay, so it depends on your computer. Let's say you have an Core i7 and you train by your CPU only, and you train only 10 categories. It may take you more than 1 hour.
Okay, that's more than 1 hour, yeah. And this more than 1 hour should be fine. I can wait for that. And a little bit about the handwriting recognition itself. So I have never done handwriting recognition training. So my question was, is this a supervised learning or unsupervised learning? Because you have to collect a lot of data for the training, right? So that was my initial guess.
Yes, this is the supervised learning. Absolutely, you need a label for every test.
Oh, I see. So what kind of data set do you use, or did you make the data set by yourself?
You know that I already involved in every step in the handwriting recognition, including the collecting the sample for training. But personally, if you do that, I think you can use some publication, some data set that are already available publicly, because the collecting costs a lot of time and also costs a lot of effort.
I see. Thanks, Khan. So this is a publicly available data set on English handwriting training, right?
Yes.
Okay. Yeah, thank you, Khan. That is quite quite expressible. Yeah, I got it. And also, like, as a last note, I would want to say that if I knew about the true and false that you showed in the ambiguity while writing, so I would have done it in my primary school and then have got a lot of I have always passed in the exams. Thank you, Khan. It was really interesting.
Thank you. So you can drop me, give me any questions. You already have our contact in Togo Techies, so you can contact me anytime if you.
Yeah, thank you, Khan. Yeah, I will do it.
Thank you. Okay, so we have another questions from Mark. Okay, thank you for your presentation. My questions: what are the state-of-the-art solution for offline handwriting recognition? Okay, so I will answer the first question first. So the state-of-the-art now, you will see this is the CNN, everything based on the CNN, but there are a lot of more model to recognize the handwriting, the offline handwriting. So you can use something similar to YOLO or SSD. Yeah, some more model like that. And at the first try, and then you can improve from that. But basically, the offline handwriting is recognized by the CNN model. Okay, the second question: can AI make even doctor handwriting readable? Thank you for your questions. I think it's very fun. So if we have, I did not try it before, but if we have the data set and then we train it, somehow we can recognize, but I think that the recognition accuracy is not so high. Yeah, maybe just around 50%. I think so. Even that, no normal people cannot read it, right? Thank you. Okay, so the next one from Trần Hill. Yeah. So the character Q&A in slide, the last slide, creating from AI. No, it's a real handwriting from human. Thank you for your questions. Yeah, of course, we can make the genetic handwriting similar to that. Yeah. Okay, so the next questions. Okay, about from Mạnh Trung Lê. So can you take a little bit about your own neural network of handwriting recognition? Okay, so for the first questions, nowadays, okay, so this is my own neural networks. Okay, so here, back to the university time. So when I research, I start with the segment and decode method, but then it's soonly defeated by the continuous method, and then everyone changed to the end-to-end network. So in that end-to-end, you need the encode and decode step, and also some kind of attention. So in the encode method, you can use several layers of LSTM, and then in the decode, you can use the same. And for the attention, there's many kind of attention, and I think each of them also have advantage and their own disadvantage. So my recommendation is that you try to combine some kind of attention together, and you may get the best recognition rate. And also, I need to mention that after that, you need some language model to boost your recognition rate a little bit. And for English, the other language like English handwriting, you can use the model that I already introduced in this presentation. And yeah, and for the decoding step, you can use the CTC. Yeah, it's the best one until today. Okay, what kind of data set how you use for train, validation, and test? Okay, so about the data set, it depends on the language you want to train. So if you want to train about handwriting mathematical expression, there are some data set called Jerome. This is available freely on the internet, and you can download and train in it. And yeah, there's a lot of kind of data set, but it depends on the language. So if you can specify the language, so you can contact me later, and I can give you the name of the data set you can use freely. Because the collecting is very complex and costs a lot of time. So each language is collected by different groups. That's why. Okay, so what kind of neural network are you using? Okay, so like I said, like I mentioned before, for the mathematical expression, we use end-to-end. And for the normal, like Japanese, English, we use the LSTM with CTC. Okay, how many layers of deep neural network do you use if in case deep neural networks? Okay, so again, it depends on the complexity of your input. So normally it's 3 bi-directional STM to 7 layers of the same. So yeah, maybe the easy one should be the English, and the complex one maybe Chinese, Japanese. Yeah. Okay, and do you use if in case if how do you avoid the overfit problems? Thank you for your question. So yeah, this is very technical questions. Yeah, of course, I made a lot of overfit problem when I train the data. So first of all, so you need to separate your data first. Make sure that you separate, split your data to training, testing, and validating correctly. So it's one reason to one solution to avoid the overfitting problems. Or you can use some reduce the layers in your deep neural networks, because if you add more and more layers, it will cause overfitting. And if you use CNN, so you can increase your dropout rate from more possible. In the first stage, you use the drop is about 0.3, so now you can try 0.5, so it may avoid overfitting. Yeah, many solutions.
Hi, hello, can you hear me?
Yes.
Yeah, I'm Chung. Yeah, I'm come from Taipei. I just asked you some question about that overfitting problem. Okay, but I could not get your answer because the overfitting problem is a major problem in the AI learning. And overfitting is that means that when you change the database, it learns very slowly. It stops learning, stops improvement at some point during the training. Okay, so because of that one, it come from like something very come from noise or something very special, not a feature of your object detect. So you learning the weight and the BR is very slow change, and every neural network they already change to that like gradient, like stochastic gradient descent, right? You need to calculate the change of that one, and there are many methods to over this kind of problem. Like you can extend the database, like you have a 50,000, you can extend to 100,000. With more data, you can learn more the feature, useful feature of the object. Is that one, but extend the data is very expensive during the practice. Another problem, maybe you can use drop-out method also. This one can also help you to avoid, or the other one like L2 regularization, right?
Yeah, you're right.
Yeah, the L2, L1, and I saw that in your neural network you one kind of softmax, right? The softmax is that you change the output into a probability.
Yes.
Yeah, but I'm not sure this one can help you can help you to get the good result in the final. But this one can only help you with the speed only. You can have that like sigmoid function. You can have a like find function. Many like activation function can help you to that. Okay, but overfitting is not like you just change many layer. It can help you to resolve the problem. Deep learning, if you have a many layer, the learning will be paid to another of we call that vanishing gradient problem.
Okay, thank you for your comments and suggestion. Yeah, you're very useful.
Yeah, that's my suggestion. Thank you so much.
Thank you so much. Yeah, just because we don't know, we do not have a lot of time here, so I just mentioned about some basically steps we can do to reduce the overfitting problems. So if you want to discuss more clearly about that, so you can contact me later. So it's so I know it's a very technical problem for everyone. So I don't want to mention too deeply about that. Anyway, thank you for your questions. Yeah, I really appreciate that. Okay, so we have a next question from Phương Nguyễn. Which application of handwriting recognition do you want to do in the future? So yeah, I want to make my own font of handwriting into my computer. Maybe it's not the easiest one for me in this moment. Okay, so how can you detect the important bonds from the characters? Okay, so this will take time to explain for you about this one. So basically, you can check it by based on the velocity or the angle. There are many geometric features on the online handwriting. You can check when. Okay, and yeah, it's Please drop me a question later so I can answer more detail to you. Okay, so thank you everyone.
Hello. Can you hear me?
Yeah, please.
Okay. Can you go back to the slide with convolutional neural networks and LSTM?
Okay. I believe this slide.
Oh yeah. So okay. Firstly, thank you for your presentation. I did not know about using LSTM for handwriting. I only knew about CNN. So, but from experience, I know that LSTM layers take a long time to train because of the gate parameters, right? It has a lot of parameters. So I just want to know for the 3 convolutional layers, firstly, you're receiving an input in 2D image format, right? And you're using 3 convolutional networks. So I want to ask, is it to reduce the image dimension also?
Okay.
To reduce the number of nodes for LSTM layer.
Okay, thank you for your questions. So here, from the input, so because we only have the basic input, that the background and the drawings, so we can simply transfer the input into the gray image. That means only from black to white. So it's just the 2D image. And then from that 2D image, you use the 1D sorry, 1D convolutional to extract the features in just a series of number. I mean that. And then you apply 3 times and you have a long series of number. Do you understand me?
Yes, but are there any pooling layers to reduce the dimension of the image? Because for LSTM layers, the number of nodes are, if the number of nodes are too big, it's there will be too many parameters, right?
So thank you for your question. So in this tutorial, in this step, we do not apply any pooling layer. We we input them directly into the STM layer. If you want, you can insert some pooling layer here. No problem. For your information, if you train by this architecture, you can got the recognition rate for all the categories about 75%. Thank you.
Thank you very much.
Okay, so if you have any questions, so please contact me later. Contact Tokyo Techies later, and I will answer all of your questions. So now we move on the next section. Thank you.
Yeah, that's fine. Go ahead. Skip it.
Yeah, so thank you, Han, for such an insightful presentation. And thank you guys for participating very actively during the Q&A session. The questions were really good. So before we finish, I would like you to quickly take a moment and fill the feedback form. I mean, it's very easy. You can just scan the QR code and that QR code will take you to the link for the feedback form, and you can just fill in the feedback form. And if you would like to have the slides for the webinar, you can put in your email addresses there. And yeah, this was the first episode, and we'll be organizing these webinars in the future as well. So please follow us on our socials, on Facebook, on LinkedIn, on Twitter. And we have also created our Instagram profile as well. So please look out for all the updates. And not only webinar, we'll be posting interesting stuffs regarding the IT related stuff, I mean, related to cybersecurity, cloud computing, software development, and any other things as well. So yeah, please follow us. And yes, it was nice to see you guys today. So hopefully we'll see you next time. So take care. Bye-bye.
Bye everyone.
Goodbye.